Welcome, Hornets, and thank you for joining me today. Today we're looking at part 4 of the General Integration Practice number 2, where I will be going through numbers 12, 13, and 14. So the last 3 problems from the worksheet that has been given to you. Now please keep in mind that in these worksheets I am going through our basic integration rules, including natural logs, working with completing the square, or general trig, and replacing with our arc trig formulas. So please keep that in mind. So on your screen you will see numbers 3 through 14. If you have not taken a screenshot yet, please take this moment to get one. Alrighty, here we go. We're going to start with number 12. Number 12, we are looking at the integration from 0 to 2, and we have 1 over x squared minus 2x plus 2 dx. Now what we're going to do is we're going to complete the square by looking at it as an x squared minus 2x plus 1 by breaking off 1 from the 2 and looking at the 1. This will allow me to see the pattern that I want for my arc tangent. Notice how I end up having x minus 1, the quantity squared, plus 1 squared dx. This immediately allows me to go to my u substitution if I want, or go directly to my pattern. My pattern is 1 over a, where a is 1, u is x minus 1, so I have the arc tangent of x minus 1, and we're going from 0 to 2. When we plug in the 1, we have the arc tangent of 1, minus, we plug in the 0, and we have the arc tangent of negative 1. Now we do have to be careful because the arc tangent of negative 1 is in the 4th quadrant and is the opposite of the reference angle at 1. So we are looking at the arc tangent of 1 is pi over 4, and we are subtracting the negative of pi over 4. The double negative applies, and we end up with pi over 2 as our answer. And this is our answer to number 12. This then brings me to number 13. Number 13 is working with the integration from negative 1 to pi over 6 of x minus 3 over x squared plus 1 dx. And in this problem, what you'll notice is that the power is dropping by 1. When the power drops by 1, we're going to be looking at a u substitution. So if I let u equal x squared plus 1, my du is going to be a 2x, and we have dx. Now you'll notice there is no 2x up there. As a result, I want to make sure that I take out this 2 and call it 1/2 du is equal to the x dx. Seeing that allows me to recognize that I'm going to break it up into 2 separate integrations. The first one, x over x squared plus 1 dx, and the second is going to have the minus 3, negative 1 to pi over 6, and I have 1 over x squared plus 1 dx. Since we've already done our u sub here, we can clearly see that we have the integration from negative 1 to pi over 6 of 1 over u du. In the second piece, we can clearly see our arc tangent pattern that we're going to work with. And then we just do the 2 pieces. 1/2 the natural log, and I have my x squared plus 1 from negative 1 to pi over 6 minus 3 arc tangent of x, once again from negative 1 to pi over 6. Now I used my calculator at this point, recognizing that I'm looking at ugly pi squared over 36 plus 1 for a natural log, and I don't know what that is, any more than I know what the natural log of 2 is when I try to subtract. So I decided to just use my calculator and find my decimals, plugging in one value at a time to find my answer. I ended up getting 1/2 of this result, and that turned out to be negative 0.2254. Subtracting, I have 3 times, and I got 0.2675 minus 0.7853. Subtracting and multiplying by 2 left me with a positive 1.5534, and I simplified to be 1.3280. And there is my answer for number 13. This brings me to number 14. Number 14 is working with the integration from 2 to 3 of 2x minus 3 over the square root of 4x minus x squared dx. As I did before, I'm going to use u equals my 4x minus x squared. I'm going to get du equal to 4 minus 2x squared dx, minus 2x dx. And I notice that I have a 2x, but it's not quite the same. So I'm going to subtract 1 and add 1, and this will now give me 2x minus 4, and then I have a plus 1 and the square root of 4x minus x squared dx, integrated 2 to 3. This one will have the dx, square root 4x minus x squared, integrated 2 to 3. Now, the problem I have is I have to flip this around so that I have a positive 4 and a negative 2x. So I'm going to bring out a negative. This is going to give me the minus 2x plus 4 that I want, and my dx, and my square root, and I'll be able to use a u. This is going to give me negative u to the minus 1/2 du from 2 to 3. Over on this one, I'm looking at my arc sine pattern. So I'm going to complete the square. I'm going to have add 4, subtract 4. So you'll notice I've got an x squared minus 4x plus 4 dx. And this is going to give me 1 over square root 2 squared minus x minus 2, the quantity squared dx. I can now go to my u sub first, so that's going to add 1 to the power, that's going to give me 1/2, and I end up with a negative square root, 4x minus x squared, and for this one, I have plus. And we're now working with the arc sine. Once again, this is 2 to 3, and then we have our arc sine. This is x minus 2 over 2. From 2 to 3. And just as I did before, I can already see I'm going to get radicals and all kinds of things, so I used my calculator with this, and I ended up getting 0.5358 from the fundamental theorem of calculus with the first part, plus 0.5238, doing the fundamental, 35, excuse me, using the fundamental theorem of calculus with the second piece. When I add them up, I get 1.0594. And that's the answer I'm looking for. So here we have our answer to number 14. This has been the worksheet that I gave you for the general practice on integration. I hope this has helped. If you found it helpful, please remember to click like. If, however, you have constructive criticism, please feel free to leave me a note, and I will do my best to improve. Thank you very much, Hornets. Please be safe, take care, and have a fantastic day. Cheers.